Hello, welcome to the notes on areas of parallelograms and triangles. You will have to turn these in and submit them at the end of watching, so please make sure you write down everything that I write down. Okay, so the first thing we're going to talk about is parallelograms. Now, parallelograms have two sides that we refer to, two measurements, a base and the height of it. Now, the bases could be either one of the pairs of parallel sides. So in this picture, it's the top and the bottom. However, I could tilt this parallelogram. If I could pick it up and kind of rotate it and sit it on this base right here, it would have a different height. But either one of those is fine. Another thing to note is that this height does not have to start at this corner. A lot of times it does. I could drop that height down anywhere because the height is the perpendicular distance between the two bases. So this could also be the height. And as you see, both of those have the same length. So the area addition postulate says that the area of a region is the sum of its non-overlapping pieces. So if I could take this triangle right here in a parallelogram, imagine that I could transform it and push it over to here. What I would get is this picture on the right. Now the picture on the right looks like a different shape that we know the area for, a rectangle, where it has a base and the height still. So this little piece of the triangle was a part of the base. When you shift it over here, this is still the entire base. So therefore, the area of a parallelogram, the formula is base times height, just like a rectangle. Again, if I could take this triangle and put it over here, I would form a rectangle. In a rectangle, we know the area is base times height. Same for a parallelogram. So our first example here, we're going to look at a parallelogram and we are asked to find its perimeter and the area. The perimeter of any shape is the distance all the way around it. So here it would be 32 plus this side plus 20. So because it's a parallelogram and we learned that opposite sides are congruent, this entire length down here is going to be 32. If this side is 20, the side across from it is 20, opposite sides are congruent in a parallelogram. So the perimeter is going to be 2 times 32 plus 2 times 20. That is going to equal 64 plus 40. And so that gives us a perimeter of 104. And then our units on perimeter are the same as the lengths. It's inches. Now for the area of a parallelogram, we need to know the length of the base and the height. Well, the way that the height is drawn right here, we have this dashed segment, that's the height. We're going to need to find it. We have the base, it's 32, so I would plug that in here, but I need to find the height. Hopefully, we all look at this and see to find the height, we have a right triangle. We are missing one side of it. We have the other two sides. That's good old Pythagorean theorem. So it's going to be h squared plus 12 squared equals 20 squared. So that's h squared plus 144 equals 400. H squared is going to equal 256. So the height of this parallelogram is going to be 16. We take that value, we're going to plug it in right there. So the area of this parallelogram is the length of its base, 32, times its height, which we found to be 16. This is going to equal 512. And now anytime you find the area, it's units, so in our case, inches squared. So finding the area here is going to be a little trickier because in that last example, I had, okay, if this is 9, I know this side's also going to be 9. This is the altitude, so it's perpendicular. I am missing this piece. Now, there's nothing that says that when I drop this altitude, this point of intersection is halfway in between. So I can't assume that that's 6. It might be, but it's not the case all the time. So therefore, I can't make that assumption. So to find the height of this triangle, we're going to have to use something different. When I look at this triangle, the first thing I notice is this 45-degree angle. This degree sign kind of moved and shifted down here. It should be there. So what I notice is we have a 45, 45, 90 special right triangle. In a special right triangle that's 45, 45, 90, we have leg, leg, leg root 2. So I could equal those two, 9, the hypotenuse is equal to whatever the leg is, and we need the leg, that's the height, times the square root of 2. Divide both sides by square root of 2, and what we end up with is that the leg is 9 divided by the square root of 2. I'm going to rationalize this denominator because we can't leave radicals in the denominator, so it's multiply top and bottom, numerator and denominator by square root of 2 over square root of 2, and we end up with 9 root 2 on top, square root of 4 on the bottom, it's 2. So now the area of this parallelogram is its base, 12, times the height that I just found, because the leg is the height, 9 root 2 over 2. I can cross cancel if this is over 1. That's 6. I get 54 square root of 2, and I have no units, so I could just write a little lowercase u and square it. Remember, most of the time we are going to want your answers to be exact, so don't approximate. I could have, by the way, used this and done Pythagorean theorem. It would have been h squared plus h squared, because the legs are congruent, equals 9 squared. So you get 2h squared equals 81, and then simplify that for h. You would get the same exact answer if you did it that way. Next up, the area of a triangle. The base is any side of the triangle. It doesn't have to be the side that the triangle is kind of sitting on. Like I would call this, that the triangle is sitting on that side. It doesn't have to be that way. Every single side of the triangle can be considered a base. But now, depending on what the base is, the height changes. The height is the length of an altitude drawn to the given base. Now the altitude has to start at a vertex and then intersect the opposite side, the base, at a 90-degree angle. Again, it doesn't hit the base at any specific spot. In fact, sometimes if you have a triangle, the altitude is not even inside of it. Okay, in this obtuse triangle, this altitude is perpendicular. It's from the vertex perpendicular to the base, and it's not even in the triangle. The area congruence postulate says if two figures are congruent, then they will have the same area. So if two figures have the same exact size, they're going to have the same area. Should make sense. So here, if I take these two triangles, this one where I have the base and a height drawn, and then I kind of flip it over and I draw it this way, that base times height, same triangle, those have the same area. Hopefully you see that when we put these two triangles together, what we end up with is a parallelogram, and a parallelogram's area is base times height. So if I have two triangles, their area is base times height. So what would one triangle be? Going back here, together, two triangles, base times height. If I just want one, I would have to divide this by 2. So that's where we get base times height over 2, or 1/2 base times height. You guessed it, 1/2 base times height, or base times height over 2. So either of these equations, they're equivalent. 1/2 base times height or base times height divided by 2 is how we find the area of a triangle. All right, so this picture, we are finding the perimeter and area of the triangle. And what we mean here is this orangish, goldish triangle. The white one is kind of not there. These dashed lines imply that it's kind of invisible. It's not there. The reason that it's drawn here is because that clear or white triangle is going to help us find the height of this orange triangle, because the area of a triangle is the base times the height divided by 2. I have the base, it's 29. I don't have the height. How will I find the height? I'm going to use this information that they gave me with this triangle next to it, and I will find the height by doing Pythagorean theorem. So I get 6 squared plus h squared equals 13 squared. H squared is going to end up equaling, all in all, 133. So the height of this triangle is the square root of 133. So to find the area, it's going to be 29 times the square root of 133 divided by 2. That gives me an area that's approximately 167.2 centimeters squared. The next part of this asks me to find the perimeter of the orange triangle. The perimeter of any shape is adding up all the sides. So here it would be h square root of 133 plus the base 29 Plus, now I need to find this missing side. I need to find the hypotenuse of this triangle in order to find the perimeter. So let's go ahead and do that. How would I do that again? Well, that's Pythagorean theorem. Once again, when you have two sides, whoops, I have the height, square root of 133 squared plus 29 squared is going to equal, let's call it x squared, okay, where this side's x. Squaring a square root, you get 133. Squaring and square rooting undo each other. 29 squared is 841. And this equals x squared. So x squared is going to equal 974. X is going to equal the square root of that. Add those all up together, use your calculator. It doesn't tell me exact answer. If it did, I would check if 974 could be simplified, but this is going to be approximately 71.7 centimeters. Remember, perimeter is just your units, area is your units squared. All right, this next problem is a very popular type of area problem for a triangle. It says the height of a triangle is 7 inches more than its base. The area is 60. So we know the area of a triangle is 1/2 base times height, or base times height divided by 2. Now, I don't know the height of this triangle, but it's 7 inches more than its base. So if I just draw a triangle for myself, I drew this one. It doesn't have to look like this. I'm going to call the base x. The height here in this triangle is 7 more. So that would be the base plus 7, because it's 7 more than the base. My picture is off, right? X looks longer than x plus 7. That's okay. My picture is just for me to be able to visualize what I'm doing here. So I'm going to take this equation, and I know certain things. I know the area is 60 square inches, so I plug in 60. This is going to equal half of x times x plus 7. Now, as soon as I see that 1/2 and it's a multiple, it's a factor on the right side, I'm going to double. I'm going to multiply by 2. I'm going to multiply by the reciprocal of 60. I'm sorry, of half. So I get 120 is going to equal x times x plus 7. So what I have here is I'm going to have 120 equals, I'm going to distribute the right side. I get x squared plus 7x, and I see that this is a quadratic that I'm going to have to solve. So because I have an x squared term and an x term, I have to get this equal to 0. So I subtract 120 from both sides. And now I'm going to look for two numbers that multiply to be negative 120. And at the same time, they have to add up to 7. So we're going to look for factors of negative 120 that add up to 7. Whatever they are, because my x squared term has a 1 in front of it, I'm just going to throw them into these parentheses with the x. Okay, so factors of 120, I thought 120 times 10, that's not enough, but 120, 8, and 15, those two numbers will work. Which one's negative? The 8. How do I know that? Because it has to add up to positive 7. So this factor should be x minus 8, x plus 15. Using zero product property, I get x is equal to 8, or x is going to equal, from the second parenthesis, negative 15. Because x is the side of a triangle, it's the base of it, for sure it cannot be negative 15. I can't have a side that's negative. So my answer is the base is 8 inches, because it's x. The height then is going to be 8 plus 7, 15 inches. Here is a very, very helpful triangle area formula that you're going to use if you don't know the altitude of a triangle. So what this area is it's going to be either 1/2, and then you take side B times side C times the sine of angle A, or 1/2 A times B times the sine of angle C. So it's side, angle, side. Or 1/2 A, side A, times side C times the sine of angle B. All of these are equivalent and depends on what you know in the problem. I wouldn't worry too much about memorizing like B, C, sine of A, although because you're going to have numbers and your triangle doesn't have to be triangle ABC, it could be triangle cat, triangle dog, whatever, okay? But the fact is you're going to have two sides and then the angle that forms them. That the sides form that angle. All right, so let's take that formula and put it to use here. We are going to find the area of triangle ABC, and then they gave me two side measures, AB and BC, and they gave me the measure of angle ABC. I, for one, have to draw this, and I would suggest you do the same thing every single time. Now, I don't know anything about this triangle, which side's the shortest, which side's the longest, so I just arbitrarily label the vertices. I know it's triangle ABC. I label them. However, just this is a visual for myself. So AB is 14, BC is 18, and then angle ABC is 65. So notice how I have a side, an angle, and then the side. So this is a side angle side situation. So the area of this triangle is going to be 1/2 side, side, sine of the angle between those two sides. I use my calculator to find the approximate answer. Type this in, make sure you're in degrees, not in radians. How you check that, press the mode button, which is to the right of second, and it should say degrees. The highlighted box should be around degrees, and then you get 114.19, and this is in meters square. All right, so again, notice that I wasn't so concerned about little a times little b times sine of big C. I wasn't worried about that. I know it has to be half the two sides times the sine of the angle between them. Okay, that's how I remember this. I don't worry too much about exactly remembering that formula. It has to be a half side, angle between them, sine of it. Okay? All right, so for this problem, it does tell me that it's a little trickier and I will have to recall other trig. But right off the bat, I may not know that. So first, I'm just going to sketch my triangle like I normally would. I'm going to fill in what I know. So angle N is 37 degrees, angle O is 93 degrees, and then segment MO is 13 degrees. So with that special area formula, we need a side, then an angle, then a side. I don't have that here. I have an angle inside. Right? So if I was to write that out, this is what that would be. So what I have to do is find a side that will give me side, angle, side. It's going to be this one. So how am I going to do that? Hopefully you recall that angle, angle, side, when you have that situation, it's going to be the law of sines. So using the triangle sum theorem, I'm going to find angle M. I take 180 minus 93 minus 37, and I get that angle M is 50 degrees. So now I'll call the side across from angle M little m. So little m over the sine of 50 is going to equal, now I use a side angle pair that I have, both of them, so it's angle N and its side across from it, so 13 over sine of 37. Let's cross multiply. I'm going to cross multiply here. I have m times the sine of 37 equals 13 times the sine of 50. Divide both sides by the sine of 37 degrees. Put parentheses if I want. Using my calculator, I get that m is approximately, it's approximately 16.55. Now, if I'm going to round, I should store that answer into my calculator because I'm going to have to use an approximation to approximate at the end. Or what I could do is just leave this as what little m is. Okay, so now I'm ready for the area formula. Area is going to be 1/2 13, because now I have side, angle, side. 13 times this 13 sine of 50 over sine of 37, which I could store if I want, times the sine of, let me zoom out here a little bit, sine of 93 degrees. Let's go ahead and type that into our calculators, make sure you get the right answer. All right, I typed it in, and sure enough, I get that the area is approximately 107.41. My units are centimeters squared. Last problem that we're gonna do here, and it's gonna be equilateral triangles. We're going to be asked to find the exact area of an equilateral triangle. I do believe we did this earlier with special right triangles. If it's equilateral, right, all three sides are the same. The altitude is dropped down. And now what that does is it splits in an equilateral triangle. The altitude is the median, is the angle bisector, is the perpendicular bisector. So all of those, the sides, the bottom side, the base gets cut in half. Now another thing is, in an equilateral triangle, all the angles are 60. 60, 60, 60, right? So on top, I get 30. So I'm hoping that you all realize this right here is a 30, 60, 90 triangle. Each side is 12. All right, if that side is 12, this side is 12, this entire side was 12. When I drop that altitude, I split it in half. So each of these is 6 and 6. I need the height because the area is 1/2, the base, which I know is 12, times the height, which I'm going to find right now. In a 30, 60, 90, it's all in terms of the short leg. The short leg is across from the 30-degree angle, so this is L, this is L root 3, and this is 2L, which makes sense because it's 2 times 6, right? The hypotenuse is always double the short leg. So therefore, if I know L is 6, if the height is equal to L root 3, the height of this triangle is 6 root 3. I will take that, I'm going to plug it back into my formula, so area is going to equal 1/2 times 12 times 6 root 3. Let's simplify this. 2 goes into 12 6 times. I would be left with 6 times 6 root 3, that is 36 root 3. My units are inches squared. So whenever you have an equilateral triangle, that's what you're going to do. Whatever the side is. If this is 4, 4, and 4, drop that height, that altitude down, splits this into 2 equal pieces. This is 2 root 3. So then don't forget though that the area, the base is that entire length on the bottom. All right, that's it for this day of notes. Your homework is day 1. Thank you so much for watching. Have a great day. Bye.